So the last time we were working, we made a program for closed loop that would simulate a automatic light system, and we wanted it to go on and off automatically, and we used 2 branch functions to do that. Today instead, what I'd like to show you is how to use a little more sophisticated decision element to make that decision. So let's verify first that I'm connected to my interface, and I am, and I have my sensor connected to port I4. So I'm going to change that to analog 5 kilo ohm, because remember I'm using a photo resistor there. Alright, and as usual I'm going to start my program with the start icon. Now before, we used 2 analog branches to make our decisions. However, once you're in the higher levels, you have access to a lot of more sophisticated displays and those kinds of things. So let me show you instead how to use a different command. Let's go to, under Program Elements Expanded, let's go to Branch Weight, and you see here we have a regular branch with a data input. Alright, and here is a comparison with a fixed value. So that's the one we're going to utilize today. Alright, and so what I'd like you to do then is, in inputs and outputs, okay, we can actually tie a variety of elements in here. So this is a universal digital input, this is a universal analog input. So if you'll connect this there, remember that A is tan, so it needs a tan object connected to it. Right, and it says I1, so I need to change that to I4, and I need to change it to the type of sensor I'm using, a photoresistor. When I do that, the input mode here will change automatically, so I'll say OK. Alright, and once I do that, let's connect the start. Right, and let's look at the test interface to remember, right, what happens as it gets darker in the room. The output of the NTC resistor goes higher, and I believe the last time we used 1500. So let's change this value to 1500. Alright, and it says A question mark 1500. So this branch will be if A is less than 1500, this will be greater than, and this would be equal to. Now we're not really going to have the equal to very much, so when you have that branch, we'll just tie it to one of the other ones. So if A is less than 1500, it is light out, right? So if we go here to basic elements, what we want to do is we want to have the light turn off. I have my light plugged in as a motor to M1, so I'm going to change that to lamp off. Okay, and then I'm going to put this here, right, and lamp on. Okay, so when A is greater than 1500, we want the light to turn on. Alright. Alright, once the light turns on, what we'd like to do is we want to go back and continue to evaluate this loop. So we'll go here and come around and go back. Alright, if it's less than, it's daylight out, and we want the light to go off. So we do that, and then after the light goes off, we want it to evaluate. Now, so I can hook it here like this, or I could have gone around to the top. Either way, it didn't matter. I have an open pin, and that's equal. You should have noticed in lab that on these analog sensors, it's very unlikely that you will get a exact equal. Alright, so we just want to tie, in this case, that one to one of the other legs. So we'll take it here, alright, and we're going to tie that one into light on. So that would probably only happen briefly, just as the sun is setting, and then that moment will pass. So let's run our program now and evaluate. So I'll start the program. It's daylight out, you see, and my light's staying off. It's flickering back. So now as it gets dark outside, you'll see that it's staying in that branch. Alright, and as the sun begins to come back out, it begins to go the other way. So now you can see what's happening and how you can use this comparison block to replace two others. This comparison block, there are a lot of powerful comparison blocks here, and this is called comparison with a fixed value. So it lets you take different paths based on the number there.